It's fun to speak to you again. It's very seldom that I get that they let me up twice in the same day. Usually they'll cut me off once. So I'm excited to spend a little bit of time this afternoon talking to you about a somewhat esoteric topic, right? I think this is an important topic to understand insofar as it really will identify not just where you can go with Kubernetes and where we think the community is going to go with Kubernetes, but it'll also hopefully provide a little bit more context into what's happening under the covers of Kubernetes. Now, many of you are likely pretty expert in the Kubernetes environment. Hopefully, I won't be teaching you a lot about some of the core concepts of Kubernetes. You'll have encountered these already, but hopefully this will provide you a slightly more nuanced way of thinking about how these things tie together and be able to understand where this is going. So in many ways, this is really a conversation for two audiences. One is, it is an introductory conversation around Kubernetes, but it's also a conversation for systems engineers, just helping you start to think about where we might go in the future and some of the things that we might be able to build together in this community with this technology. So, I'm sure everyone has told you today already what Kubernetes is. You already know what it is, right? And everyone answers, it's a container orchestration system, right? And it is. If you think about what happened, through history that got us here, it was pretty clear that, containers were happening, and to make them accessible to organizations, you needed to have some system that could provision them, wire them together, and deal with them. That's created a lot of value in and of itself. And I think the value that organizations experience is really built around two vectors, right? The one vector is in terms of resource efficiency. And I already talked this morning about how the use of containers can drive significant resource efficiencies inside organizations. The other side of the house is developer and operations efficiencies, creating this API-driven interface that enables you to get more out of your infrastructure. Have a principled set of APIs that you can use that replace all of your ticketing systems. Both of those are really powerful. But it doesn't at the heart of it really tell you what Kubernetes is at the lowest level. And one way to think about it is Kubernetes is just a big old database, right, with some other fancy stuff around it. It really is, right? If you start digging into under the covers what exactly is happening in Kubernetes, you have a database, etcd, and then you have some other clever stuff around it that enables you to take a statement of intent from inside that database and materialize it in the environment in a specific way. So you could think about Kubernetes as this union of two things, a database and a set of controllers. The database is where you store your declarative intent. The controllers are the mechanisms whereby you materialize that intent into the outside world so that you can get something up and running in a production system. And as you start kind of spelunking into the architecture of Kubernetes a little bit, there's really these sort of two divisions that you can think about. You can think about it as a control plane and a data plane, right? Inside the control plane, there's a couple of elements that are key. We've already talked about etcd. etcd is, in many ways, the sort of heart of the system. It's the representation, for a declarative system, you need to have a place where you store that sort of declarative intent. And you need to be able to do that in a way that's reliable, is partition tolerant, has all these wonderful properties. And etcd is that thing. Now, the primary thing that you interface with as a developer in the Kubernetes ecosystem is the API server. Turns out that's the primary thing that everything interfaces with in the Kubernetes ecosystem. And what the API server is really doing is looking at a way to materialize a set of resources that are persisted in etcd, and then represent those resources to the broader subsystem. Now, you have the API server, and then you have the set of out-of-the-box controllers that are provided to you as a user of Kubernetes, right? And these really come in two binaries. The one binary is the scheduler. We'll talk a little bit about what the scheduler does. The other binary is the controller manager, and that's basically packaging up all of the out-of-box controllers that exist in the Kubernetes ecosystem. And then those set of controllers interface with the API server, right? As do the elements of the control plane. So this is the kubelets that are the local daemon that manage the state of Docker containers in the environment. They all speak back to the API server. By and large, all interactions are from these controller elements into the API server versus vice versa. There are some cases where that's not true. So for instance, if you look at log inspection, port forwarding and proxying, Those are the types of things that, container exec, when you sort of exec into a container, those are outbound from the API server, but almost everything is inbound into the API server. And this is a pattern that enables us to get to a point where we have a pretty robust system, and it's really built around this idea of controllers. Now, this is something that's really important to understand. So much of what went into Kubernetes was working to create an effective control system. There's a lot of control theory that's gone into this. If you look at people like Brendan Burns, who was one of the co-founders of the project, he's kind of a robotics geek, right? So you spend a lot of time thinking about control problems. You think about the way that, what we saw inside the Borg and Omega team that, people like Brian Grant and Tim Hawken brought to the table. It's really around this control metaphor. And so this is, perhaps the most important thing about Kubernetes. At the heart of it, all it is a way to take declarative intent and materialize it through a set of controllers into your environment, right? So you basically say, hey, I want to do this thing. The controller will register with the API server, watch that. It will understand what state exists in the API server. In some cases, particularly the kubelet, it will understand what states exist in the outside world. And it becomes a big reconciliation loop, right? So the controller basically is responsible for taking what's supposed to be and making the world look like that. This is a very powerful pattern, right? It's a very robust pattern. It means that if something goes wrong with the controller, it has an opportunity to retry. All of the operations are idempotent. And as a result of that, Kubernetes really becomes a sort of shotgun-proof system. I've heard some customers describe it as. You can just randomly unplug racks and the system will tend to recover because these controllers are decoupled and they're all being watched by something else. And that makes Kubernetes kind of interesting. Now, one way to sort of really ground this as a sort of early user in Kubernetes, if you're not that experienced with it, is to look at what happens under the covers when you start to interact with the system. So for instance, I'm a user, I want to create a new pod, right? So I call the API server and it says, okay, I want to create a new pod. Let's write that into the etcd state. Now there's a controller that's responsible for watching the set of pod definitions and detecting if there's an unbound pod, which means a pod has not been assigned to a node. And that's called the scheduler. So the scheduler will then say, okay, this pod is not bound to this particular node. I need to make that happen. So it basically creates a record binding that to the node. Now the kubelet is sitting there and it's looking at its node definition in the API server, and it says, oh, hey, there's another pod that I should launch. And so it will go ahead and configure that pod and make it work for you. And so at each of these stages, it's really about API server proxying for etcd as a state of truth, and then a set of controllers manipulating the state inside the system. Now, one of the things you'll observe here is that there's a lot of interactions. A relatively naive implementation for something like Kubernetes would have been to implement a bunch of polling in this, like polling subsystems. Like, okay, I have a bunch of things that are polling the API server all the time. The problem, obviously, with that is it will introduce varying latencies and a lot of pressure on the core system. So what Kubernetes has introduced is a watch mechanism. So you can basically register an API object. Something else can then register to watch that API object. And if something happens inside that API, inside that resource collection, you get notified and you can update it. This obviously creates a much more kind of snappy and sort of reactive system than you would be in a polling state. Now, one of the interesting things, and this is sort of something that we got a lot of feedback in the early days of Kubernetes, is that it doesn't feel that snappy when you're using it, right? Like, sometimes I do something and it'll take a little while for a pod to materialize. There's a reason for that. This is a control system. Interestingly enough, if you have control systems that don't have dampening, what happens? Hysteresis, right? All kinds of bad things happen. And so a lot of thought went into the control metaphors inside Kubernetes, not just in terms of creating the mechanisms that can create an incredibly dynamic and reactive system, but also the mechanisms you need to back off enough so that you don't get unintentional behavior through too active or too aggressive a set of control metaphors. So at the end of the day, when you start thinking about Kubernetes, there's a lot of different kind of metaphors you can use. My buddy Joe loves to describe this as It's more like jazz than going to a than orchestral music. It's a system where you have a set of things that start to riff upon each other, and they create a set of behaviors that are sophisticated and converging, but are largely based on the behaviors of other things inside the system. So it feels more like jazz than it does like a situation where you have a conductor that's driving everything. And this very intrinsically distributed nature of Kubernetes provides a lot of the power that you experience as an engineer. It provides a lot of the robustness of the system. It makes it far more intrinsically stable, self-healing, self-regulating. It really gets you to that point where that statement of intent materializes in the production world. Another example that I've seen used and I like quite a lot is describing this as a system where you're like at a restaurant and the API server is like taking an order, and then what happens behind the scenes with all the controllers is like a number of chefs working on that order. So one order can touch a number of different chefs, but they all come together to fulfill it in the end and create that expression of intent that the customer's ordered. So that's a different way to think about the system. Now, as you start looking at this and you start thinking about, okay, so I have this database, I have this set of controllers, that's pretty neat. But one of the fascinating things about Kubernetes is that you can also start layering these things together. You can start stacking them up. Controllers don't have to reason only about pods as the underlying resource. They can reason about some of the other controllers as well. And the layering of Kubernetes is particularly powerful. So you can start looking at the sort of most basic primitive inside Kubernetes, which is a pod, right? So you all know what a pod is. It's a collection of containers that have a shared fate, right? So the role of the scheduler, when you look at the underlying system, is to identify a node, when there's an unbound pod, and say this node has the appropriate set of resources available for me to run this pod. So it has enough CPU, it has enough memory, maybe it has enough GPU, or whatever the set of resources are. It then identifies that node, and that pod is now bound to that node. Now, these pods, can't be relocated. The idea here is that a pod is always bound to a single node. It can't be moved around. There's a good reason for that, which is you don't want to have multiple entities with the same intrinsic identity in a distributed system when you are facing the possibility of network partitioning, right? So by making sure that every pod has its unique identity, it clarifies things in situations where, for instance, a node goes out of focus and then comes back in and has a pod that would otherwise have the same identity as another pod. So the pods give you the atom of, or this unit of compute. The pods are then configured with the security configuration, the set of containers that they have to run. You can run a number of different containers in a pod. The network configuration, the storage configuration. They're bound to a single node, and you're off to the races. Now, the next layer up in the control metaphor as we start looking at this is the replica set, right? So a replica set is the most elemental controller in the Kubernetes ecosystem in a way, in that all it's responsible for is maintaining the life cycle of a collection of similarly configured pods, right? So I can say, hey, I want 1 pod, or I want 10 pods, or I want 100 pods. And what the replica set is doing is I now have a replica set object in my API server. It's a resource. It says there has to be, like this replica set is now configured with this. And that controller then looks inside the API server and it reconciles whether there are enough pods in existence to map its state. So if there's not, it's going to drive the system to that desired state over time, right? And so in this case, it could be 10 pods. I might change my mind the next minute and say there should be 100 pods. I don't, or say, maybe I say there should be 100 pods. I start scheduling them up. I might change my mind and say, okay, now I need 10 pods. The lovely thing about this system is I don't have to wait for the system to configure the 100 pods and then dial it back to the 10. It simply drives it into the latest representation of state in etcd. Now, the next layer up, so we have the pod as the sort of atomic resource that gets scheduled. We have the replica set that's managing the lifecycle of pods. The next layer up is the idea of a deployment, right? So this is a a very fancy word. Well, it's not really that fancy, but at the end of the day, you could call this simply a rolling updater, right? That's all it really is. And what the deployment object is doing is maintaining a configuration for a replica set, right? And when you want to do an update, you instantiate one of these controllers, and it will move you from one configuration to another. So it'll create another replica set, and then it just, over time, manipulates the configuration of the two so that you dial up the one and you dial down the other, until at the end of the day, you've ended up with a replica set that is operating in the correct state, right? Now, most of these sort of objects, like pod is something that is, or a replica set is something that operates like a daemon, like runs forever, right? Until you change the configuration, it will exist in a certain state. There are some situations where you want to be able to run processes once, or you want to run 10 of something to completion, which is why the Kubernetes ecosystem introduced the job as an object, right? So now you have an opportunity to start thinking about, okay, I just want to run 10 of these containers to success. And that's another useful thing. And you can layer on top of that, and again, this is just layering on top of the existing thing, the cron job. So this is something you've probably used or seen. It's just a way to schedule a job at a certain amount of time. So as you can see, the nice thing here is, in the most simplistic way, we're starting to layer these controllers on other controllers. It gets really interesting when you start thinking about custom resources. So my friend Brendan introduced this a while back, recognizing that one of two things was going to happen. Kubernetes was either going to explode, or it was going to be gated in some ways. So much of the value of Kubernetes isn't just around what is in there. It's what are the interfaces so that you can customize it yourself. I keep talking about this. One of the key missions of this community is to get to a point where Kubernetes is done. And this becomes one of those key metaphors for composability and extensibility in the Kubernetes ecosystem. And the idea here, a custom resource definition is just that, right? So it's a way to say, okay, inside the API server, I want to create a custom resource that can then be created, listed, updated, and watched as needs be by any entity inside the Kubernetes system. So it's just a way of getting structured data in and out of etcd. Nothing too fancy, right? By itself, it's not that interesting or useful. But when you start combining it with custom controllers, you can do some really, really neat things. So you're probably familiar with the idea of operators, but this is a path that's really going to get us to that next level with Kubernetes, right? So we're in a situation where Kubernetes represents a set of pretty strong basic primitives, but there's a lot of things you want to run in Kubernetes that have a mind of their own, or they need a mind of their own, right? So if you want to run a database inside Kubernetes, you're going to have to do things like backup recovery and snapshotting and a few other things. So if you start looking at things like the Oracle MySQL database operator, inside it has 4 custom resource definitions, right? So it has the basic database resource definition. It has a backup custom resource definition, it has a restore custom resource definition. And then it has a custom resource, which is basically a cron job to schedule your backups. And that's all tied together with this operator. And so at the end of the day, what you get out of that on top of Kubernetes is something that's starting to feel a lot like RDS. So it's starting to feel a lot like the sort of Amazon RDS experience, where I have an API, I can provision something, and then a lot of the life cycle of this can be handled. And this is particularly important as we start to move more sophisticated, more practical workloads into the Kubernetes ecosystem. As you start to think about things which, legacy workloads which have very specific boot sequences. I need one of these nodes, and I need to make sure that exists, and I need one of these, I need to make sure it exists, and then I need to kind of provision up the rest. The mechanics of that are now available inside the Kubernetes ecosystem. Now, this is going to take us a long way into the future, I think. The problem is it's kind of hard to write controllers. It's not as easy as it ought to be, and there's some pretty nuanced things you need to do. Fortunately, how many of you have seen the Meta Controller project? Right. So this is something that's really neat. It was written by a Googler, and what it's done is try to create a relatively standard way to construct a controller. So a lot of the controller staples are implemented in this one package, and then it's configured with a set of webhooks that can run random code on the back end, right? So you can start to do some really interesting things with this. You don't have to write a whole bunch of specific code. You don't have to implement all the pieces. You can just write a little bit of JavaScript, register it as a webhook, have that hosted somewhere, and it becomes part of your control metaphor, right? So the example he gave with this meta controller was 125 lines of JavaScript to do blue-green deployments of Kubernetes. So it's really powerful. Another example of the meta controller patterns he implemented was basically a composite sort of resource implementation where you could stitch together a number of these things. So this is a very interesting project, and I would definitely encourage you to take a look at it. If you're thinking about building, and this is really for systems engineers. Like if you're interested in getting something on Kubernetes and you want to, like, okay, I've been working on my own database implementation, or I'm part of an organization that's running a Hadoop distribution or something like that. These metaphors are really powerful. Now, as we start getting into the meta controller framework, it becomes even more applicable to a broader array of engineers who maybe don't have the time to really kind of dig in and start pursuing some of those types of projects. So where is this all going? Like what's exciting about this? I start to look at Kubernetes, and one of the things that I really love about it is that because it's a principally architecture system, you can start doing things with Kubernetes that don't apply only to containers, right? It's pretty interesting. So if you look at some of the work that's being done to factor out the API server, and this has been a project that's ongoing for quite some time, that's a pretty useful thing to have just as a basic tool, right? So you think about it like, why wouldn't I want to be able to create and manage a set of resources on etcd that are durably persistent in etcd? Why wouldn't I want to be able to register and watch some of these resources? There's some interesting applications for that technologies. And then even Kubernetes itself as a sort of platform for platforms is really interesting. I'll give you one example. So inside Heptio, we've been working on this project called Gimbal. How many of you heard of that? Just a couple, right? So this is a really interesting project. We were asked by an internet company to build out a system that could manage 6 million inbound concurrent internet connections into 25 Kubernetes clusters and a bunch of OpenStack clusters, right? That's a pretty fancy system to build. And we started looking at it and really thinking about it, and we're like, holy crap, it's not that hard, right? If you start looking at Kubernetes itself as a framework for managing configuration, it's a great place to host and run a whole bunch of Envoy proxies, right? So, hey, we can sort of extract Envoy out of the Kubernetes environment and run a bunch of L7 elements in this environment. We can then create namespaces that represent each of those clusters. We can create custom resources that can deal with things like the scraping of Kubernetes configuration and handling, maintaining that linkage. We can use the Kubernetes authentication system. So at the end of the day, we were able to produce something that's like, I think it's got good taste. You should make up your own mind, but it certainly works pretty well. And it was very easy to implement. We could not have done that without Kubernetes. It would have been a tremendously more complex undertaking to try to build something like Gimbal, except that we had this platform to build on. And that is fascinating. So when I think about the future and the shiny things that it holds, I think we're going to see some really interesting advances in this space. I think we're going to start to see a situation where organizations are going to build domain-specific platform as a service offerings on top of Kubernetes, right? We're going to get to a world where Kubernetes has extracted essentially the essence of platform as a service, some of the best attributes of it in terms of being able to construct an environment where you're able to, through an API, deploy a piece of code and have it run for you, but at the same time start to introduce the set of services that you need to build a sort of holistic application, right? So whether that's something that's provided to you by a third-party provider, whether that's something that you build yourself, you can start to stitch together like the first class set of services that you need to run a set of applications. And all of them will be provisioned through an API, and all of them will be easily managed through some of these autonomous systems that we're looking at putting in place. So I'm really excited about where this is going over the next couple of years. And definitely, if you have thoughts, you want to chat ever, reach out. I work at Heptio, and I would be happy to take a few questions since I think I've got a couple minutes left. No questions. I should have talked for longer. Okay, wait. I've got to throw the... Actually, I'm not going to throw this. Someone else can throw it. I'll injure someone.
So you're talking about using Kubernetes as a way to basically leverage its API functionality where you write state and that state is then picked up by workers. Does that not feel to you like that could be separated from the Kubernetes project as a separate, useful API framework system?
Can absolutely. And we're doing it. Well, I mean, not we, like the Royal, like not me, but the engineers are actually doing it. Yeah, so they are breaking out the API server as a discrete project, so that you have the ability to do, basically all it's doing is a way to create resource objects and just drop structured data into etcd, register watches, and it's a really useful building block. So yeah, they are absolutely extracting that and making it accessible to other projects.
Does it have a project name or?
It's just the API server extrication. I don't know what they're calling it. But no, it's something that has to be done. Like if you look at the way that the system's structured, one of the really nice things about Kubernetes is that the team has been incredibly diligent about only using public APIs for everything. So if you look at the fact that the API server, and all of the other control plane elements could have been bundled into a single binary, but they weren't. Folks were very careful to make sure that they all use the same public-facing APIs as users could access, and it's created a sort of well-structured, well-architected system that has more applicability. I think there's a fair amount of nuanced work that needs to be done to do that API server extraction and to make it sort of generically useful to everything else, but it's absolutely something. Brian Grant in particular has been thinking a lot about this, and the community's pretty excited about it.
Yeah, good stuff.
Cool. Any other questions?
Hello. That's actually an interesting point, but it's not a single binary versus something like Docker Swarm or Nomad is a single binary. I know people say it's like harder to deploy Kubernetes because of that reason. Do you see people taking the Kubernetes API and turning it into an easy to deploy something like that, or do you don't see that happening?
I think if your biggest problem is copying 3 binaries instead of a single binary, you've probably got bigger issues in life.
People seem to have that issue. I don't know.
I don't know. I mean, it's a fair point. I mean, there's a philosophical argument to be made around like what level of coupling makes sense. Whether you want to be able to, what your update metaphor is, whether you want to be able to have it factored so that you can do, if you have to patch a subsystem, you have a small subsystem to patch. I mean, I'm not going to weigh in on the philosophy of it. I could see a lot of ways to sort of factor and bundle it back together. I think the key thing is like being fastidious about API first development and making sure that you never cheat. It's kind of important. I've seen a lot of systems where the set of interfaces you project to the user are one thing, but then you have a lot of other things that kind of come in behind the scenes and either connect directly to the database or do something else. Having those 2 elements, for instance, directly connect to the etcd data store would be a disaster, right? Like, so first and foremost, yeah, it makes sense to have a single entity proxying for that. Whether you wanted to bundle that into a mega single binary or not, I think that's just taste. The key thing is just making sure those interfaces are public, accessible, and useful.
So the way the operator framework or operators are used right now is, for example, you mentioned that databases it's being used. So do you see that instead of packaging an application, which is a complex application which requires 3 or 4 dependencies, etc., instead of, right now the de facto standard is Helm charts.
Yes.
Instead of using that, do you see this operator pattern coming up in which, let's say a complex application have an operator and you only expose the template variables as CRDs, and you can define what the upgrade path should be, what different configuration should be handled. What do you think about this?
Absolutely. I think this is kind of key. So if you look at one of the things that is also happening in the community right now, we see a lot of ISVs, software vendors, repackaging their applications for Kubernetes, right? So you're a provider of Kafka, right? And you want to be able to get it out there into a user's ecosystem. If the starting point is get a good certified Kubernetes cluster up and running, is step 1. Step 2 is blah, like it's like just run this kubectl command, right? Like your life gets a whole lot easier. For you to be able to do that with a lot of these more sophisticated systems, it's not enough to just deploy a binary. There will always be this operator component to it. When you start thinking about the update semantics, there may well be custom resource definitions that get bundled up and deployed as part of that. So as I think about the future of distributed systems, delivery, consumption, etc., we have to get to a point where whatever that packaging format is makes allowances for these operators. Absolutely. Any other questions for me? All right. I have time for one more if anyone wants to ask. All right. Well, thank you, folks.